Hello, I'm Neeraj. Today I will explain how we can do fine tuning of a pre-trained large language models or LLMs. But why we need fine tuning? So this is very important question. Generally what happens, we train all large language models by using a vast amount of global knowledge. But several times we want that model should apply the concept of domain adaptations and work on a particular domain. Several times we want to use the pre-trained large language models to a particular kind of task. Several times due to privacy and security, we want to use large language models, pre-trained large language models to a very personalized kind of tasks where we assume that we didn't train large language models on those personalized documents. Hello, I'm Neeraj. Today I will explain the concept of fine tuning of large language models, and I will also explain that how we can fine tune the large language models. But before going into the detail, first of all we have to understand that why we need fine tuning of large language models. Actually what happens, large language models are pre-trained on a vast amount of linguistic resources or knowledge resources. But the problem is, suppose you want to use such kind of pre-trained model, but the problem is, suppose you want to use such kind of pre-trained language models for a very personalized and secure kind of task where you cannot disclose your documents, your resources and knowledge to outside world. So in that case, you can use the pre-trained large language models and fine tune it and use it for your task. Several times you need domain adaptations kind of facilities so that you can use the large language models and adapt its facilities for another domain. And several times you want to use that knowledge which those large language models contains for a very particular kind of tasks. So in all scenarios, we generally use fine tuning of large language models so that we can enhance the quality of end goal. So what are the things which supports in fine tuning? So first is transfer learning. Actually, all large language models contains a huge amount of pre-trained knowledge and it contains a lot of features, so we can reuse both pre-trained knowledge and features in a particular kind of task, in a personalized kind of task. Second is representation learning. So it contains contextual embedding and hierarchical features. Contextual embeddings means how the context can define the meaning of word and how with the change of the context the meaning of word can change. So such kind of contextual embeddings generally defines such contextual scenarios, and there may be some hierarchical language representations which shows that how the things are related to each other. So we can use all those informations in our personalized tasks. Third is regularization effect. So regularization effect generally how we can use the large language models to reduce the chances of overfitting, and we can optimize our system to perform a particular task. As the large language models contains a huge amount of knowledge, so a targeted use can help us in controlling the overfitting and help in regularization effect kind of things. Fourth may be like optimization efficiency. So it is already well understood that if you want to develop your large language models or similar kind of models by pre-training it by using your own data, then it will require a lot of resources. But here you can do with the entire thing with a very little effort and resources. Next is empirical success. So it is already given in a lot of research papers, bias and fairness considerations. So this is also very clear. Now how to do this? So there are a approach. So we can define this approach like this. First of all, you can load your pre-trained model. In our case, I have used the Llama 3 model that I downloaded from Hugging Face website. After that, you can prepare the dataset. And once you prepare the dataset, so first of all, load your pre-trained Llama 3 model, because here I am using the offline version of Llama 3 model. And after that you have to prepare the dataset. So this is very important part. Prepare dataset means for what kind of task you want to develop or fine tune the pre-trained large language models. For example, suppose I want to fine tune our large language model for a very simple task, sentiment analysis. And our scenarios are like, we want large language model can understand our sarcastic sentiments related stuffs, and it can work well in our scenarios. So this is our task I have taken. But suppose you want your fine tuning system, means after fine tuning your pre-trained large language model will be expert for question answering. Then you can train that large language model for a particular domain specific question answering. You can do it for summarization. You can do it for anything, guided summarization. You can train it for writing essay, or you can train it for a particular domain specific knowledge inferencing. So based on your requirement, you have to prepare the dataset. After that, you have to tokenize the dataset, and then you have to divide the dataset into train and validation set. After that, you have to apply the padding, so that because what happens, the text sentences may have a different length, so you have to pad it to a unique a common length. For example, maximum based padding, minimum based padding, or some fixed length based padding. So you can apply any of those things. After that, you have to design the training arguments, and then initialize the trainer. You have to set the hyperparameters, and after that you have to fine tune your trainer. You can use some pre-trained tokenizers, and after that you can evaluate your model. You can use the pre-trained model configurations. If any errors happens, to update it, and then you can save the model. So now I will go through the code, like how it is actually working. So in this code, I have used the sentiment analysis based system. So here you can see that I have collected from internet and some from means different online versions of large language models platforms. I collected some sarcastic kind of sentiment of text, and then identified their labels, correct labels. And based on this is our training data set. So I want my Llama 3 to fine tune to identify the sentiment of such kind of sarcastic. So here I want the pre-trained Llama 3 model will identify the correct sentiment in the case of such kind of sarcastic statements. So first of all, we converted this data into panda data frame, and after that we use the train and validation split. So here from this it is clear that for train we are taking the 80%, and for test we are taking validation we are taking 20%. So we take the train and then we call the model. So where our llama 3 model is there. So actually after downloading we kept our model here. So I just give the absolute address. After that we call the tokenizers from the pre-trained model. Next thing is like to identify the padding. So padding is very important, because suppose the your first sentence length is 10 and your second sentence length is 5 and the highest sentence length is 10. So in that case you have to make the second sentence also length 10. So you will just fill the padded information like 00 or something to make it idle, make it equal length like a 10 10 kind of thing. So here we are adding padding for that purpose. After that you can apply the tokenization, so convert into tokens. So you have to apply the same thing for train and validation both. After that you have to take the labels and map it. For example, label equal to 1 if the sentiment is positive or otherwise 0. So such kind of labeling you have to do. And after that tokenized train, so you have to map the label according for train and validations. And after that you have to remove the original sentiment columns from the tokenized train and validations part. And after that you have to update the model config if the padding token is taken. So this is like a auto model for sequence classifications. You have to just call that model, and the number of labels are 2 because here we are using the classification task. If you are using regression task then it will be different. You can use multi-level classification task also, and you can use the sequence to sequence task also. So based on that your so here it is just like a sequence classification task is there. So based on that, suppose you want to use this fine tuning process for some causal reasoning, then you can use auto causal reasoning kind of model specification. So based on that you can call any the specified type of models. So here just we are using sequence classification, so we use similar kind of models from the Hugging Face, because it contains a lot of coding stuffs like how we can do it. But here as we directly call it from the library, so it do it it does all the, it fulfills all the basic requirements. After that we resize the model based on the tokenizers, so that it becomes the means similar sizes, same size. After that we define the data collector with padding. So again this operation's main purpose is to make the data size equal. Now the training arguments are there. So training arguments are like where you have to keep your data, means where you have to put your trained output. So I had when I trained I tried to put it here. So and then evaluation strategy epoch means after the end of each epoch the system will evaluate the accuracy. And per device train batch equal to 8, per device evaluation batch equal to 8. So it is the batch size that system will consider to train and evaluate. And total number of training epochs are 3. You can take it more. So weight decay is 0.04, means this is a L2 regularizations just to reduce the overfitting scenarios. And after that we define the trainer like that. So trainer is like a model, which model we have to train, and then training arguments, what are the training arguments that we defined here, and then training data set, what are the training data set, what is the evaluation data set, tokenizer, and the data collector. So everything we have identified, then we call the trainer.train. Then it will train the entire system and upload the model here. So here I had uploaded the model. So a little difference in size you can observe after so it is 14.9, and here it is around 14.5. No, both are same. So a little differences may be there, very small level differences may be there. So once you train, your model will be stored here. So after storing this model, you can check it whether it is working fine or not. So for that you can test it. So for example, I again call the torch and then transformer, auto tokenizer, model sequence classification, panda. Then we call that updated model. This is our updated model. So we call this updated model, and after that uh, we call the tokenizer and model from the updated model, and then data we have. So data contains so when based on that we have converted the data into panda data format and then tokenize it. Again here instead of like a pad token, I just selected US token so that it can detect the end of sentence also and pad also. And after that we tokenize the function and then tokenize the test data set, fully tokenize the test data set, and then apply it for predictions part. So in the predictions part, it generates the predictions, and then we can just map the predictions by sentiment map, and then it can generate the answers, predicted sentiment, and then we can print the predicted sentiment. So when we run this algorithm, I have found this. So actually the system added some special tokens based on the differences, and then it predicted like this. This movie was fantastic, I really enjoyed it. It was positive, and I didn't like this movie at all. It was very boring, so negative. But the scenario is like that. Before fine tuning, I found that even if just to take the same example, I will make the code available. You will find that before fine tuning, the system will give this sentiment as a negative. Means instead of calling the updated model, where I kept the updated model here, if you just call the original model, you will find that the first answer is not correct. So this kind of differences I found. So this way our goal was to fine tune the llama 3 model to make it highly effective for a sarcastic kind of sentiment classification, means classifying a sarcastic type of text into positive or negative sentiments. So it did its task perfectly. So this is the main purpose of this model fine tuning, llama 3 model fine tuning. Similarly, you can do it for multiple different tasks other than classification. Even I tested the same kind of model fine tuning for summarization task, for question answering task, and for guided summarization task, and for private causal relations kind of data also. Means we have fine tuned the llama 3 model for private causal relations kind of data. And it was highly successful. Only thing is like it will not run. It will, you have to just use a more number of epochs other than just 3 epochs. And other thing is like I have tested this system in a laptop having 16 GB RAM, but for that we had made a lot of changes. First, I am using PyCharm. So in the PyCharm, I have increased the memory setting. Here you can see that 30 GB. And in the case of system's virtual memory, I have made is the paging memory size like a 50 GB. Only then the system will run. Otherwise, system will not run because it is a highly memory and processor consuming task. So thanks for watching, and I will make the code and data that is used here publicly available. I myself took the code from multiple different places because I have used the library specific codes, and which are so a lot of examples are there for those library specific codes. So I considered those things in preparing this tutorial. So thanks for watching.